Hello friends, a very warm welcome. This is Ishant on behalf of Edureka, and today we will be discussing about threads in Java. Now, threads is something which is one of the most important topics in Java, and you must have some, hands-on specialization in this topic. So let's see what we got for the day. So we're gonna see what is a Java thread, what is the life cycle, how we can create a thread, what is this main thread in an application in Java, of course. Then we'll see multi-threading in action. And lastly, we'll see what exactly is this thread pool. So to begin with, what is a Java thread? So guys, a Java thread is a lightweight sub-process. Now in an application, so we have one main thread. So when our application is running, so operating system is going to create one process. So same way over here, Java virtual machine will take care of your Java applications. So process would be created and each and every process will have a main thread. So thread is a lightweight sub-process. So here it is the smallest independent unit of a program. It contains a separate path of execution, and every Java program will have at least one thread that is something known as the main thread. So main is nothing, it's an execution context where the certain jobs will be executed one after the other in a sequence. Now, if you want to create a thread in Java, so we got this thread API from the java.lang package itself. You need not to even import it. So it's by default in the lang package. Once we create a thread, it will have a life cycle. So how it's gonna work, right? So a thread can lie only in one of the shown states at any point of time. So typically, guys, we'll have a thread with a state called new. So when you create a thread, its state is new. Then we move into the runnable, then into the running, and finally the thread will be terminated. In between, a thread can have the waiting state, which can iterate between your runnable and running. So let us have a look on to individual states. What exactly is what state? So having a new state means that we are going to initiate a new object of a thread. You can even say that the thread is just born, right? It's just like creating an object of a thread in the memory. Thereafter, once a thread is created, we start the thread. So once we start the thread, the state is changed to the runnable state, right? So that it can run. And finally, your thread is now running. So running means it is executing a run method, which is the method we have to override from the thread class, right? And we even have the yield method that can send them to go back to the runnable state again. What is waiting state? When a thread enters a state of inactivity, so thread is not performing any action, it is waiting for some other thread to give back the data, or it is sleeping, or it is blocked at certain scenario or a use case. So that is known as a waiting state. Your thread is not currently resuming the tasks. Finally, the thread is terminated. So when your thread has completed its task, right? So it is terminated. Now let us take one example of this thread. Consider that you are going to play one audio file in a media player, right? So let's say you have a media player and you're going to play an audio file. Now the moment you tap on the button to play that audio in your phone or in your PC, right? So a new thread is created. And you see that finally the thread starts proceeding. So your song starts to play. So from the runnable, it enters into the running state and it keeps on running till the song is not finished, right? So that's like the terminated. So in between, you just go for the pause, right? That's like where your thread is now doing the wait operation. So when your song is automatically finished or you stop the song, that is the terminated state. So one of the just an analogy that how the thread is going to work for us. Same way, there can be a use case that you want to download some image from the server. Now, threads are typically used when we have to perform a long running operation, right? So there we create this thread. Downloading an image can be a long running operation because it is dependent on the network speed. Now, when you want to download an image, so you create a new thread. So in the background, what we will do is we'll start fetching the bytes from the server for the image, right? And in the running state, your thread is continuously fetching the data. There can be a state called waiting. Let's say network connection has been disconnected. So our thread can wait until the network connection is, re-established. And terminated would be a state when the image is properly downloaded. So a couple of examples demonstrating how the life cycle of the thread is supposed to be. So now we will look into how we can create a thread. So guys, if you want to create a thread, right, you need to understand the reason why you want to create a thread. So we by default will have a main thread in our application that is represented by the main method. So what is the main thread, right? So typically whenever you run your Java application or any application, you will write your code in the main method. Now the code in the main method is executed as a main thread itself, right? So main method will have the instructions written within it, and all those instructions are being executed as a part of the main thread in a sequence, one after the other. Now, what will happen if you are going to do a long running operation within the main itself? It can take time, right? So the below written instructions in the main method, they will be blocked because of a long running job, right? Now that is where your operating system, it will start giving messages to the user that this application is not responding. Would you like to wait or kill this application? So this is what we need to understand, right? So when we have long running operations, we need not to put the load on the main method or the main thread. We need to create a separate thread. So that is what we are going to understand now. So creating a thread is like what now? We have two different ways by which we can create the thread. Either we extend from the thread or we can implement the runnable interface, right? So guys, having a thread class, so we'll just say extends thread. Any class name extends thread. You override the run method, you create the object of your thread class, and we invoke the start method, which will internally execute the run method. Same way, so here you can see a bit of code snippet coming in. So there can be a class called myThread extending the thread. We have a run method which will do some job, and in the main method you create the object of the thread and you just say start. So start method will internally execute the run method. The way we got thread class, in a similar way we do have something known as runnable. Now many a times we are already into inheritance, right? So let's say your class is inheriting some other class. Now it cannot inherit thread at the same time because multiple inheritance is not supported in Java. So what we got runnable interface. So if you are already extending some class, you cannot extend the thread class, but we got a runnable interface which can be implemented. Rest of the structure remains the same, right? So you override the run method, create the object of the class, and invoke the start method. So guys, here we go, right? So your thread class will implement runnable. So let's now do a little bit of coding here and understand that how it's going to work for us, right? So I'm going to write a new Java project. We'll see how we can create threads using the thread API and the runnable interface. So I'm going to say threads demo. Let's say next and say finish. So we got a small Java project created here in the SRC. I'm going to write a new class and I'm going to say threads with the main method, or I will say this as app with the main method, right? So app means application here, app with the main method. Now when we have this main method coming in, so guys, we will come here and say that main method represents main thread, right? So main method represents main thread. So whatever we write in here will be executed by main thread, and Threads always execute the jobs in a sequence. So whatever the job you're gonna give to the a thread, they're gonna execute in a sequence. For example, I will write down one of the job. It goes like application started, and thereafter I can have a job called application finished. So in between, I can have, let's say, a small job. It will print some documents for me, right? So I'm going to say that for int of, let's say, document 1 till the document number 10 and document plus plus. So I'm printing some documents, right? So let's say this will be some code snippet, right? So some code to print the documents, right? So this guy is printing some documents for us. So I will write down the CISO statement here. So printing document plus the doc, right? So whatever the document we are printing, so I'm just putting up here. Now, when I will run this program, it is all CISO statements. It's nothing complicated to understand. I hope so. So your application started. We printed the document 1 till the document number 10. So we are printing these 10 documents in a loop. So you see, everything is happening in a sequence. So what I'm trying to say is that this goes like your job 1. Consider this entire snippet as job 2. And this goes like, let's say, some job 3. So we are not getting job 3 before the job 2 or job 1 after the job 3. So what is the output? Output is a sequential output, right? Now that is what a thread is. So what is a thread? Thread is an execution context. So what does this mean? This means that it's gonna execute your code in a sequence. Threads always execute code in a sequence, right? So one after the other. So this is one of the demonstration regarding the main thread, which is nothing represented by the main method. Now what I will do is I will write one class here. Now this class goes like some my task, which let's say my task. So my task is going to execute a task for me. So this will execute a task for me. Here what I'm gonna do is I'm gonna say CISO. So even we'll put up a loop here, and this loop goes like a similar loop. So printing the document number document, right? So here I'm going to put some different delimiter so that we can understand. Printing document number this from printer 1, right? So this is from, let's say, printer 2. And coming here, I'm going to say this is your printer 1. So this is how we are going to come up and understand. So my task over here is having a method which is going to print the document, but this guy will print the document from the printer 2. And this guy over here is going to print the documents from the printer 1. So within the job 1 and job 2, I'm going to introduce this job called my task. So my task is a new my task, right? And coming here, I will say task.execute the task. If you will see now what we have done, we have made my task as job 2 and this guy as job 3, and this goes like job 4. Now, when I will run this code, what you will find is that application started, printing of documents started. So printer 2 is in use, and thereafter printer 1 is in use, right? So as per our discussion, main is executing everything in a sequence. And to your surprise, you need to understand this point here, that till this task is not completed, below written jobs, they are blocked. I need to now mention this point. Till job 2 is not finished, below written jobs are waiting and are not executed. So this is something which we need to understand because of sequential operation here, right? So we are seeing a sequential operation. So that is the reason till job 2 is not completed, below mentioned instructions or the jobs they are waiting. Now, in case job 2 is a long running operation, right? So in case job 2 is a long running operation, consider this guy is going to print several documents, right? There can be some several documents which we are supposed to print. Now, till these several documents are not printed, right? In case job 2 is a long running operation, that is several documents are supposed to be printed, right? So this is a use case which, so in such a use case, OS/JVM shall give a message that application is not responding, right? Or we will have some, you can say, behavior, some sluggish behavior in the apps. Now, what is meant by this sluggish behavior in the app? It means that we will be able to see some kind of apps which are hanging, right? So you see that apps, they are going to hang, right? So even I can say app seems to hang. Now, why app will seem to hang? Because your main thread is blocked, right? So the only point here is that your apps, they might seem to hang. They will have some sluggish behavior in case you are doing a long running operation within the main thread. Now, this is the use case where we need a thread. So I think the use case is clear, right? So what I'm going to do is, so this my task, you come up with this my task in the same way. So let me comment down this code part. So instead of having it a normal class, you make it a thread. You override this run method with the public, because run in the parent is public. So you need to override it. So this guy is overrided here for us, right? The run method. So I get the same operation being performed, but this goes in the run method and my task is now a thread, right? So I can very simply understand that my task is a thread, because inheritance makes this relationship to come up as is a relationship, right? So my task is a thread. So guys, this is certainly clear to everyone, I hope so. So in the next part of this is like what now? So you won't say execute the task. So rather we will come here and say task dot start. So start method internally calls the run method, right? So start shall internally execute run method. Now let us re-execute the same code and see what is the outcome. So we see a similar output here, right? But if you can observe, application finished is coming somewhere in between. Previously it used to come in the end. So I'll give a rerun again. Now I see a different output, right? Application started. Sometimes printer 1 is being used, sometimes printer 2 is being used, and thereafter a lot of times printer 2, then sometimes printer 1, and then the app getting finished. So again, rerun this application, you see again a different output. So every time when you will execute your code over here, what you will see is a different kind of an output, right? Why now the outputs are mixed for us? Because along with the job 3, job 2 is executed parallelly, right? What I can say now, so now main and my task are executing both parallelly or concurrently. That is the reason you are able to see a mixed output for both of these threads. So guys, when you write a thread, thread's gonna work parallelly to your main thread, right? So now my task is also known as a child thread, or sometimes the terminology can be a worker thread. So child thread or a worker thread, right? So this guy is going to perform certain operation which will not affect the performance of the main method or the main thread, right? So we are having this main thread which is not supposed to be getting affected by the operation of my task, because my task is executing separately, main is executing separately within the same process, of course. So they are not interfering in a way that it has to be waiting for one guy that it should stop, it should finish its execution, then the main will resume. So we are getting the things executed in a parallel operation. Now the same thread called my task can also be created. So considering that you have a class called some CA, right? And I'm just gonna comment down this guy now. So considering that we have this my task extending CA and thread both. Now this is not allowed in Java. Multiple inheritance is not supported, right? This is an error. Why? Because multiple inheritance isn't supported. So what we will do? So we'll come here and we will say extend CA, but don't come up with the thread. You can say implements runnable. So that's just one basic change here. Rest everything remains the same. So guys, in case your class is already a child of some other class, right? So if you are already having this inheritance implemented, so you won't be able to write comma thread. Multiple inheritance isn't supported in Java. So you can anytime come up and say implements runnable. Coming here, you are now going to do it in a different way, right? So let us see how we can create the object. So you can say runnable R is a new of my task. So you write a polymorphic statement. The reference variable of the interface is pointing to the object which implements it. Then I will create a normal thread object. I will say thread task is a new thread within which I'm going to pass this runnable reference, and then I will say task dot start. So this is a bit of change when it comes to runnable versus your threads. So you run this code here. So it's gonna work in the same way for us, right? So it's again a thread. So printer 1 or printer 2, right? So they are now the mixed outputs. Mixed outputs, they definitely show that our jobs are getting executed parallelly. So main is not getting affected now, right? So that is how we are able to understand this point. So every time you will run this code, you might end up in looking the different outputs. Why different outputs? Because execution of threads is not in our hands. It is in the hands of JVM. JVM can perform time slicing. It can give some time to the main thread, some time to the my task, right? So that's how we are able to understand the threads in Java. Guys, I hope you have understood it. So now we shall be proceeding towards the next part. So the next part over here is to differentiate between thread class and the runnable interface, right? So guys, there is some common things and some dissimilarities. So over here in thread and in runnable, so a unique object is created for both of the cases, right? So memory consumption of course increases because we have a separate thread running in the same process. Then class extending the thread cannot extend any other class because of the multiple inheritance. But here runnable helps us to perform the same use case. So if you are already extending, you can implement a runnable. So thread class is extended only if there is a need of overriding the other methods of it. So if you are actually inheriting the thread class, so you might be looking forward to override its other methods as well. But in case you don't want to do that, runnable is the best use case, right? Because runnable, you can only have this run method which you can override. Then having thread, we got tight coupling, and runnable is loose coupling. So of course, guys, when you have a loose coupling, dependencies, they gets reduced and is a better use case to use. So moving ahead now. So I hope thread versus runnable is good to go. We saw how to create a thread, what is a thread, and how it is helping the main thread to accomplish the jobs. So what is this main thread? Once again, main thread revisited. Guys, main thread is the important or the most important part of any application or a Java program. So whenever you run your application, your main thread is executed. So every program will have this main thread, and Java main thread is needed so that we can spawn the child threads. We can create child threads, we can start them. You have seen that we created my task, we started the my task, right? So it must be the last thread to finish the execution. That is, the main thread stops the program, terminations. So it's gonna terminate the program. So when your main thread is finished, so it is basically a termination of your application itself, right? So Java main thread, guys, how it's gonna work? Let's see that part now. So typically, JVM is going to start the main thread and some other daemon threads at the same time, right? So when you run your application, the main thread and the daemon threads, they are started by the JVM. Your main thread can further start multiple child threads. For example, child thread A, child thread B, and the threads can further start the other threads. For example, thread A can start the thread C. So if we talk about our example here, so there can be my task, there can be your task. For an instance, we can have some other guy called your task, right? So this guy is working on some printer 3, right? So we can have these multiple threads which can be spawned in the main method itself. So here I can just say thread your task is a new thread. In between I can pass a new of your task, and then I can say your task dot start, right? So it's one the same story. Either you write this polymorphic statement or you directly pass the reference. So these two instructions can also be, written in a way of a new thread, and in a new thread you pass a new of your task, and then you simply say the start, right? So you can conclude it in a single statement in case you want, if you don't want to have the reference to the thread. So these threads, right? So they can be multiple threads here and there. So now we see multiple threads in action, right? So if you want, you can have your threads in a lot of threads executed from the main thread itself. Even what we can do is from these threads, we can execute some other threads. So that is what we were trying to understand. And one more thing, any thread can be marked as a daemon thread. So you can just say task dot set the daemon as true, right? So what is this daemon thread? Daemon thread is a thread which is going to be executed by the JVM whenever the application starts, right? It's gonna execute the thread along with the main thread. If you see the image, that is a bit about how the main thread is going to be executed. So now next part is multi-threading in Java. So typically, multi-threading begins when you have more than one thread in your process. So of course, if along with the main thread, a new thread is getting into execution, that is a perfect example of multi-threading itself. But what we are going to do is we are going to take up some use case that in case there are a couple of threads or multiple threads other than the main thread, so how they're gonna work and what can be the scenarios which we can observe when they are executed.
Please mark attendance.
സാർ ഫെയിൽഡ് കാണിക്കണേ എൻ്റെ കഴിയുന്നില്ല.
വാട്സാപ്പിലേക്ക് ഒരു മെസ്സേജ് ഇട്ടാൽ മതി.
ഓക്കെ.
ഹലോ സാർക്ക് ഫെയിൽഡ് സെൻഡ് ആണ്.
വാട്സാപ്പ് മെസ്സേജ്.
executed. So what is multi-threading? So guys, multi-threading is the ability of a program to execute more than one threads concurrently, where each thread is handling a different task at the same time, right? So that the available resources can be utilized in the most optimal manner. So let's say there's a main thread, and main thread is going to start some child threads, and there can some switching between these child threads, right? Because they are going to perform the jobs, and your time slicing will be coming into the action where some jobs of thread A will be finished, some jobs of thread B, some jobs of thread C, right? So there will be a switching between these execution of the threads. So let us see one demonstration where multiple threads can be introduced. So I'm going to write a new Java program, so a new class. So this goes like my, let's say, sync app with the main method. So this time I'm going to perform a separate operation, right? So consider that here your application started. So this is your beginning of the main thread, and this will be the ending of the main thread, right? So that is how we are considering. So main is a thread, now we understand it, right? So main is representing main thread. Always remember this, guys. So in order to prove this, what I can do is I can just try to say int I is 10 divided by 0, right? And I will run this code here as Java application. So what you see is it says there is an exception, and the term which JVM is using is thread main at line number 11. If you see this line number 11 is divide by 0 error. That's like arithmetic exception, right? So what I'm getting is thread main, right? So JVM says main method as thread. So that is one of the proof of concept. What I'm trying to say, that why main is representing the main thread, right? Now there is a class called printer. So printer is supposed to print the documents. So I'll have this guy called print documents, right? So printer is supposed to print the documents. How many documents do you want to print, right? So in begin, or let's say int some number, right? So I'm just gonna take some number here. So I will say for int I assign 1, go till this number and say plus plus. So there can be even more details in the print document, but I'm just taking one of the examples here. So I will say CISO printing document plus the I. So we are going to have this document printing done for this I. I can even take one of the name, right? So I can take doc name, and this can go like number of copies. What is the name of the document which you want to print, and how many number of copies you want. So I'll take this number of copies goes less than equal to number of copies, right? And printing instead of the document, I'm just going to have this document name. So I think this is one of the use cases which I wanted. Yeah. Now having a printer object, so I'm going to write a printer object. Printer is a new printer. This is one of the printer object. And if I want to print the documents, right? So what I will do is I will say, dear printer, please print me the documents. I want 10 copies for a document called Ishant's profile .pdf. So I want the 10 documents for Ishant's profile .pdf. So when I will run this code here, so you see your printer is printing the copies. So it has clearly said 1 to 10, right? Now, why we should be getting the documents printed here in the main method, in the main thread? We can have a separate thread, right? So I'm going to write a separate thread. So this thread goes like, let's say my thread, which extends thread, and I'm going to override this run method. Always remember, guys, you can anytime have your runnable interface or this thread, whatever the way you are comfortable, right? So here in the my thread, I'm going to have this guy called printer pref. I'm going to have a reference to the printer in the constructor. So I will take printer p here, and I will say pref is p. So in the run method here, I will say pref dot print the document. So I need 10 copies. So this is like John's profile. Or let's say John's profile is the name. So now, once I created the printer object, I'll create the object of my thread. So I will say my thread mref is a new my thread. And I'm passing the printer over here. You see, we have one object of printer, right? How many objects of printer I have created? So we have only one single object of printer, right? Only one single object of printer. So we are giving the reference. So my thread is having reference to the printer object. So since my thread is having reference to the printer object, so printer is copied to the P is copied to the pref, and you are doing a print documents here. So I will say mref dot start. Now what will be the benefit? The benefit is that printing is happening in a separate thread. That's like my thread. So now when you run this code, you see application started, application finished. So main thread is okay to go with it, right? And the jobs are getting executed for John's profile by my thread. Now consider along with the my thread, you see you got this my thread. I'm gonna write a your thread, which is very much same. All right, it's exactly the same story. So instead of John's profile, this is Fiona's profile, which we want to print, right? So the way we got my thread, in a similar way, I'm gonna say your thread. Let's say yref is a new of your thread. So it's gonna work on the same printer. So you see my thread is having a reference to the printer object. Your thread is also having reference to the printer object. But guys, what is the use case or the scenario? Scenario is that we have multiple threads working on the same printer object. Now this is a very difficult use case. So you see, printer is now going to be shared between two threads. If I start both the threads now, so I say yref dot start as well, right? So you see what's going to happen. So we are getting the documents printed. So you will run this code. So any point of time, what you will see is that the outputs they're gonna get mixed up for us. Right. So let me just keep on running this part here. So you see the outputs they are getting mixed up now. So 1 to 9 for the John, then 1 to 10, and then the John profile. So it's totally, you see the output coming here now, right? It's all mixed up. Can you imagine such a scenario in a real-time environment? So let's say two people, they want to print the documents in the printer. Can you imagine printer printing document 1 from the first fellow, and then the document 2, and then document 3, then 4? So it's all mixed up, right? So rather, what printer will do? Printer will take the commands from the multiple people, multiple computers, but it will print one after the other. So this is one of the use cases which is not good to go, guys, right? So this is certainly not what we want. So what is this? This is known as asynchronization. Threads are running parallelly. Now there can be a use case, there can be a scenario where multiple threads, so if multiple threads are going to work on the same single object, we must synchronize them. So they are not supposed to be executed in a sequence. So what I'll do is I'll introduce one more method here in this for loop here. So I will say a thread dot sleep for, let's say, 500. What is this thread dot sleep? Guys, sleep method will temporarily pause the execution. All right. So I'm going to select this guy and say surround with try catch, because sleep method will throw an exception. Now when I run this program here, so what do you see is along with some delay, the output is coming up for us, right? So let me run this code once again. But this output is not at all acceptable. Since my thread and your thread are working parallelly on the same object, so it is printing the document sometimes for my thread, sometime for your thread, which is not a real life use case. This is implemented something in a wrong manner, right? So what I can do is immediately after the start method, I can say mref dot join. So what does this join method is going to do? So it will again throw an error. So we'll surround it with the try catch block. So now what you will observe is synchronization coming into the action. Let me run this code. What you see is after putting the join, all the documents are printed from the my thread and then it is your thread in execution. Let me re-execute the program for you people. So guys, you see your John's profile, till John's profile or John's papers are not finished, Fiona's paper were not started. That is what we are able to understand as synchronization. That is by having this join method coming into the action. So if you have many people who are going to, get this printer utilized, you cannot put join on each and every, method call on every thread. So what I can do is I can come here and I can just mark my method to go as synchronized. So what is synchronized method now? So when your thread is going to execute this method called print documents, it will acquire a lock. We call it an intrinsic lock, right? Now, once the lock is acquired, no other thread can access the print documents. So rather than having the join function call, what I'm doing is I'm marking my method as synchronized. So if multiple threads are going to access the same method again and again, so what we are going to do is we are going to synchronize them. And now when I will run the code, what you see is the same output coming in for us, right? What is the benefit here? The benefit is now we need not to put join method calls on each and every thread, right? So we got this synchronized method itself. We can come here in our thread. We can say a synchronized block instead. So synchronized method was acquiring the lock on the method, right? So no other thread can access it if one thread has acquired the lock. So this is acquiring the lock as a block. Now no thread can execute or access the printer object till this block is not finished, right? So this synchronized block has to go in your threads. So there are two different ways by which we can implement synchronization using the synchronized keyword. So the output will again remain the same for us. Now, where is synchronization needed in multi-threading? We need synchronization in multi-threading when both the threads or multiple threads, they are working on the same single object. Now, that is the use case where you need to implement synchronization. So guys, I hope this is clear to everyone. What is the synchronized keyword? So now let us come back. So guys, the way we have synchronization, in a similar way, we have something known as a thread pool, right? So thread pool will manage the pool of worker threads and contains a queue that keep the tasks waiting to get executed. So there will be a queue now. We will have a lot of tasks, right, for the application which we have to do. And a pool can be maintained for these threads, which will be executed automatically by this API called thread pool. So explore this part. So what are the various thread methods, guys? So in order to create the threads, we got a thread object and then say start, right? So we can join the thread. There is something known as a thread.sleep. There can even be an inter-thread communication. So guys, we have wait and notify as methods. And a thread can be marked as a daemon thread. You just say set daemon as to what's a daemon thread. It's gonna get executed along with the main, right? So when the JVM is gonna start the app, it's gonna start the main as well as the daemon threads. So this is what we got for the day. So I hope you have enjoyed this.
I hope you have understood what he was presenting. So he just explained regarding creating the thread, he gave a demo of how to create a thread in Java in two different ways. One is using a run number interface, and the other is directly implementing the run method. So threading is one of the most important part in any of the software engineering. Um, when you start working, you will see that you will start implementing lots and lots of threads. The big problem about implementing multiple threads is the proper synchronization that he explained in the last few minutes. You have a lot of resources like semaphores, etc., for synchronizing multiple threads and for data sharing. I think you might have studied in embedded systems, and this threading also can uh, give you some problems like deadlocks where the threads cannot come out of any particular state. So there are a lot of things in threading. That's a huge subject, but I just want to introduce you to the Java threading part, and you can start kind of basic code on how to implement the Java threads. Okay, so that's all for the lecture today, and we will see you on Wednesday. Thank you.